Hi everyone, so it's Coach Red here, and I'm doing a video for geometry on a proof where I'm trying to prove segments are congruent. So oftentimes when you're using trying to prove segments are congruent, I want you to think in the back of your mind, you're going to probably, as long as it's not midpoint, you're probably going to have to use the segment addition postulate or the angle addition postulate if you're dealing with angles. So again, we always want to mark our diagram with the given, but this one's a little bit tricky to mark. So I have a process for which I do it, and you can feel comfortable doing whichever works for you. But again, I'm marking my diagram with the given. So it says PS, so this segment right here, PS is congruent to RT. So the way I do it is I actually make a line above it, and I mark my congruent marks. So like that, so you can see it. Now, I probably wouldn't have had this mark here because I think that's confusing. So you can see now why I would do that. Okay. And then I also know that PQ, I'm going to switch colors, is congruent to ST. I'm going to use 2 marks. So in your mind, you should be saying, well, it kind of means that then these would have to be congruent, right? But let me think about that for a second. Let me use numbers for you. If I told you that this was 10 and they were equal, then this would have to be 10. And then if I told you that this was 4, then this would have to be 4, which would make this have to be 6. So mathematically, we can see it. But how are we going to prove it? So let me get rid of all those numbers so we're not confused. The fact of the matter is, I'm trying to prove that QS and RS are equal to each other. And right now, I have no way of getting those little segments into my proof without breaking PS and RT into the sum of its parts. So I always call the sum of the parts equals the whole, the segment addition postulate. So what I'm going to do is I'm going to first get my given. So PS equals RT. And that's given. And I'm going to state that PQ equals, oops, it's not a segment, sorry, it's just the length. The lengths are equal. PQ equals ST. Okay, again, I want to get QS somehow into my proof, so I'm going to have to break up the larger segment. So I'm going to write that PS, another way to write PS is PQ plus QS. Look, I just got QS into my proof, and that would be the segment addition postulate. Okay, I forgot my little given there, so let me fix that. 2 is given. Okay, so I broke up PS into the sum of its 2 parts. Now I got to do the same thing with RT. So I'm going to do RT equals RS plus ST. So now I have RS in my proof. And that's going to be the segment. I'm going to addition postulate. I'm just shortening it a little bit. Okay, so I'm getting closer. Now, we've already stated that PS equaled RT. And we just gave PS and RT, I call them like new names. So now we can state that PQ plus QS equals RS plus ST. So we're basically substituting this value in for PS, and we're substituting this in for RT. So the reason would be substitution. Okay, so now our goal, if you remember, was to get QS equaling RS. I have them on opposite sides of the equal sign, but these guys, PQ and ST, they're in the way. So I have to get rid of them. And so to get rid of them, they have to be equal to each other, which in line 2 they were. So I can actually just subtract them. So I'm going to pretend subtract here, PQ minus ST. And so I would be left with QS equals RS by subtraction. And if you think about it, if they're equal to each other, let's just say they were both 2, well, then you'd subtract 2 from each side, wouldn't you? And so that's why it's subtraction. Very common proof, this proof. So remember, get your given, somehow get what you're trying to prove into the proof, often by using the segment addition postulate, by breaking the sum of the parts into the whole or the whole into the sum of its parts. And then usually you're going to be subtracting. All right, hopefully that was helpful. Have a great day.